Okay, let's unpack this. For decades, network security was all about the perimeter, wasn't it? Like a digital castle wall, everything outside bad, everything inside supposedly good, trusted, big firewalls at the edge, and job done. Or so we thought.
Right, that was the model. Simple, clear, but fundamentally flawed for today's world.
Totally broken now. Because our networks aren't neat little boxes anymore, are they? They're everywhere. Cloud, home offices, coffee shops.
Exactly. Personal devices connecting to critical data. That castle wall idea, it just crumbles.
Which brings us to today's deep dive. This really radical philosophy, zero trust architecture, ZTA. It's designed precisely for this messy reality.
It is. And the core idea, the big paradigm shift,
Yeah.
it's actually quite simple. Deceptively so.
Which is?
ZTA trusts nothing by default. No user, no device, no application. Doesn't matter if you're already logged in. Doesn't matter if you're physically inside the building.
Nothing gets a free pass. Ever.
Correct. Every single request, every connection attempt needs to be verified. Dynamically. Continuously.
Because that old model, that trusted versus untrusted zone, it relied totally on the perimeter holding strong.
And when it inevitably didn't,
Then attackers were basically inside the castle walls. And because internal traffic, that lateral movement between machines inside the network, was just assumed to be safe.
they could hop from a compromised workstation straight to the crown jewels, the main servers. It was way too easy.
Yeah. And then throw in BYOD, bring your own device, someone's personal laptop, maybe not patched, accessing sensitive stuff. That old model just falls apart.
Completely. ZTA starts from the assumption that the threat is always present, inside and out. So verification has to be constant. It's all about enforcing the principle of least privilege access all the time.
Okay. So our mission here isn't just to define ZTA. We need to get under the hood, right? Understand it's not just a product you buy off the shelf.
Definitely not. It's a philosophy, a strategic framework.
So we need to grasp its core principles, the engine making the decisions, and how you actually implement this in real-world places like cloud environments and with remote workers.
Absolutely. And if we're rebuilding security thinking from the ground up, we have to start with the foundations. ZTA has these 6 core tenets or principles that replace that old implicit trust.
6 rules for the new road. Okay, let's maybe not just list them out. What's the most revolutionary one, in your view? Is it the first one? That all enterprise systems are resources.
I think that's a great place to start, yeah. Because it fundamentally broadens the scope.
How so?
Well, traditionally, we worried mostly about servers, maybe key applications, data itself.
Right.
ZTA says, hold on. Everything is a resource. The applications, yes, but also the network switches, the routers, even the communication links between things. If it's part of your enterprise IT, it's a resource that needs protecting and evaluating.
Okay, that is a big expansion. So if everything's a resource,
Right.
what's next?
Well, it leads straight to number 2.
Mm.
Resources must be secure. The organization itself has a responsibility, meaning you have to ensure all the systems you own are as secure as possible, patched, hardened configuration, constantly checked. You can't trust the network location, but you must trust, or rather, ensure the integrity of your own stuff.
Got it. Keep your own house clean, basically.
Yeah.
So network location doesn't grant trust, but system hygiene is critical. What about the actual connection?
And that's where the next few tenets really bite. Number 3, all communication must be done in a secure manner, no exceptions, regardless of network location.
Encryption everywhere, basically. Mandatory.
Pretty much.
Yeah.
Then, number 4, and this is huge, access is granted strictly on a per-connection basis.
Ah, so no login once and roam free all day path.
Exactly. You connect to email,
Yeah.
verified. You then try to open a specific document, verified again for that connection. You try to access a database, another verification.
Wow. Okay. That sounds intensive.
It is. And it requires the 5th point. User authentication must be dynamic and strictly enforced before access. Dynamic is the key word there.
Meaning it can change mid-session?
Precisely. If something about your device's security posture changes, or the environmental context shifts while you're connected, your access can be reevaluated or even revoked right then and there.
Okay, which I guess leads directly to the final one. Number 6.
Yes. Access is determined by policy. And that policy isn't just, is this user allowed? It includes the observable state of the user, the health and configuration of the device they're using, the location, the time of day, maybe even threat intelligence. It's a whole cocktail of factors.
So it completely flips the script. Security isn't about where you are on the network anymore.
It's about who you are, what you're using, and how trustworthy that combination is assessed right now.
Okay, the philosophy makes sense, it's logical, but how does this actually work under the covers? Who or what is making these constant split-second decisions? You mentioned ZTA separates things into two planes.
That's right. A clear separation. You have the control plane and the data plane. They don't mix functions.
Okay, break that down. Control plane is,
Think of the control plane as the brain, the decision maker. It handles all the policy stuff, receives the authentication requests, evaluates the context, and makes those real-time trust decisions.
and the data plane.
That's the muscle.
Yeah.
It's a network infrastructure, the pipes carrying the actual data. It just executes the orders given by the control plane. It allows or blocks the traffic based purely on the policy decision.
Okay, brain and muscle. Makes sense.
Right.
And inside that control plane, the brain, the sources talk about this policy decision point, the PDP, which isn't one thing, but like three roles working together.
Exactly. It's a sort of triumvirate. First, you've got the policy engine, PE. This is the core intelligence.
The main brain cell, maybe?
Yeah, something like that. It's running what they call a dynamic trust algorithm. It's not just checking a password list. It's constantly pulling in data from all over.
Like what kind of data?
Oh, everything. Threat intelligence feeds, asset databases, tracking the security status of every single device, compliance rules, maybe logs from security tools, user behavior analytics. And based on all that input, the PE makes the call. Allow this connection, deny it, or maybe revoke an existing one.
Hang on, though. If the PE is the brain making decisions based on all that input, doesn't that mean it's only as good as the data it gets?
Absolutely. That's a critical point.
Like, what if your asset database is out of date?
Hmm.
Or a threat feed is delayed? Doesn't that create a huge blind spot, a trust gap?
It absolutely does. And that highlights probably the single biggest operational challenge of implementing ZTA well. The policy engine demands near real-time, comprehensive visibility.
And if it doesn't have it, if the status of a device is unknown?
ZTA philosophy says, deny. Defaulted denial if you can't verify trust. That complexity, maintaining that perfect synchronized view of everything, that's why it's hard. It needs really mature identity management, asset management, threat intel processes, all working together seamlessly.
Makes total sense. Okay, so assuming the PE gets good data and makes a decision, let's say allow for now what happens next, it passes the instruction on.
Right. It tells the second part of the trio, the policy administrator.
And the PA does what? Just rubber stamps it.
It implements the decision. So if the PE says yes, allow, the PA might generate a very specific short-lived access token or credential for that user in session.
Okay.
And crucially, it also configures the enforcement part of the system. It tells the gatekeeper what to do.
And that gatekeeper, that's the third piece. The policy enforcement point, CP. This is where it gets really interesting, I think.
Yes, the PEP is the actual gatekeeper. It could be a firewall, a secure web gateway, a proxy, even an agent on the endpoint device itself. It's the thing that sits in the path of the data flow.
And it just does what the PA tells it.
Exactly. It receives the configuration from the PA, allow this specific user from this specific device to access this specific resource for this amount of time using this encrypted tunnel, and it enforces it. It monitors the traffic, allows the permitted packets, blocks everything else.
So the decision PE and the enforcement PEP are completely separate.
That separation is key to its power and scalability.
Let's use that hospital example from the sources. Walk us through that flow. Employee needs patient records.
Okay. Employee initiates the request from their laptop. The request hits the control plane.
First stop, policy engine.
Right. PE kicks in. Checks multiple factors simultaneously. Did the user provide MFA? Yep.
Yeah.
Is the hospital-issued laptop encrypted? Yep. Is the OS fully patched? Uh-oh, maybe it missed the latest patch window. Is the request coming during work hours from an expected location? Yes.
So what happens if one check fails, like the missing patch?
The PE's trust algorithm weighs that. Maybe a missing minor patch reduces the trust score but doesn't block access entirely. Perhaps it just limits what records they can see. Or maybe policy dictates any missing patch means denial for sensitive data. Let's say for this example, everything passes. PE says allow.
Okay, PE says go. Decision goes to the PA.
PA gets the allow decision. It generates a short-lived token, maybe valid only for an hour, specifically for accessing the patient record system.
And at the same time,
It configures the relevant PP. Let's say it's a gateway firewall in front of the database server. The PA tells the PP, allow traffic carrying this specific token from this user's IP to connect to the patient record server on port X encrypted for the next 60 minutes.
got it. The PEP, the gatekeeper, now has its instructions.
And it enforces them, allows the connection. But, and this is crucial, It doesn't stop there.
Ah, the continuous part.
Exactly. The PEP keeps enforcing, but the PE keeps monitoring the context. Let's say 30 minutes into the session, the employee's laptop detects malware, or maybe they try connecting to a dodgy public Wi-Fi hotspot simultaneously.
PE sees that change in context.
Instantly recalculates the trust score. Now it's too low. PKey revokes the trust decision, sends immediate deny or terminate command to the PA,
PA relays that instantly to the PE.
and the PEP slams the door shut, terminates that active session, mid-flow, potentially milliseconds after the context changed.
That's the dynamic, continuous evaluation ZTA promises, something the old perimeter model just couldn't dream of doing.
Precise.
Okay, so we've got the mechanics. Let's talk practical deployment, because IT isn't neat anymore. We've got resources scattered everywhere, AWS, Azure, on-prem servers, plus people working from home, BYOD. How do you actually build ZTA for that mess? Yeah, that's where the implementation models come in, right? The how-to blueprints.
That's right. And the sources distinguish between underlying approaches, which are more like the why, things like focusing on identity governance, and these specific models, which are the deployment blueprints for different scenarios.
Okay, so for those scattered resources in BYOD, the resource portal-based deployment seems popular.
It is. It's often a good starting point. The idea is you funnel access through a central gateway which acts as the main policy enforcement point.
So like a single front door?
Kind of, yeah.
Yeah.
It sits logically in front of all your resources wherever they physically live, cloud, data centers, SaaS apps. Everyone, whether on a corporate laptop or their personal phone for BYOD, has to come through that portal.
And the portal does the ZTA checks.
Exactly. The portal integrates with the PE and PA to authenticate the user, check the device posture, enforce the policy, and then securely proxy the connection to the actual resource. Good for BYOD because you enforce checks before they touch anything sensitive.
Okay. Then there's the opposite extreme almost, microsegmentation. Sounds intense.
It can be. Instead of one big portal or a few large network zones, you break your network down into tiny granular segments, sometimes down to the individual application or workload.
And each tiny segment gets its own gatekeeper, its own PP.
Essentially, yes. Usually a small software firewall or gateway protecting just that microsegment.
The big win there must be containing breaches, stopping that lateral movement we talked about.
Absolutely. If one microsegment gets compromised, the blast radius is tiny. The attacker can't easily hop to other segments because each hop requires getting past another dedicated PEP with its own ZTA policy check.
But the downside?
Complexity, big time. Managing policies across potentially hundreds or thousands of microsegments. It's a significant administrative overhead compared to managing one portal or a few larger zones.
Yeah, I can see that. Okay, what about the enclave-based deployment? Sounds like a middle ground.
It often is. It's particularly useful for things like legacy applications that maybe weren't designed for modern security, or for grouping resources that logically belong together and share the same security requirements.
Oy.
Like maybe you put your entire high-security patient records database system in one enclave protected by a dedicated ZTA gateway, PEP. Then your medium security admin systems are in a different enclave with its own gateway and slightly different policies.
So grouping similar things together behind a shared ZTA checkpoint. More granular than the portal, less complex than full microsegmentation.
You got it. It provides a good balance for many organizations.
And finally, the most granular, device application sandboxing.
Yeah, this is often seen in really high-security environments. Government, defense. You're not just segmenting the network, you're isolating individual applications on the user's device.
How does that work?
Think of putting your secure email client inside its own virtual container or sandbox. If that email client gets hit with malware, the malware is trapped inside that sandbox. It can't easily access other applications, like your document editor, or compromise the underlying operating system. Each sensitive app lives in its own little protective bubble.
Wow, okay, that's serious lockdown. So these models give us ways to apply ZTA, but ZTA doesn't live in a vacuum, does it? It has to work with all the security tools we already have. Or maybe it forces us to rethink them.
Both, really. It definitely forces a reevaluation. Take identity and access management, IAM systems, things like Active Directory, LDAP, modern cloud identity providers.
ZTA needs those, right?
Absolutely critically. ZTA is impossible without strong IAM. The policy engine needs that authoritative source to know who the user is, what their roles and permissions are, what groups they belong to. IAM provides the essential who context for the trust decision. Garbage in, garbage out applies heavily here.
Okay, What about encryption? We said it's mandatory. Usually that means TLS.
Yes, TLS is the baseline, but ZTA often pushes organizations towards mutual TLS,
Yep, sure. Meaning.
meaning not only does the client check the server certificate, like your browser checks a website certificate,
Uh-huh.
but the server also checks the client's certificate. Both sides have to prove their identity cryptographically.
That sounds much more secure.
It is, but
Right.
it creates challenges.
How so?
Well, think about traditional network security tools like intrusion detection and prevention systems, IDPS. They often work by inspecting the actual data packets flowing across the network.
But if the traffic is fully encrypted end to end with MTLS,
The IDPS can't easily see inside the payload anymore. It might see the encrypted tunnel setup, but the actual content where the threats might be hiding is opaque. So you need different inspection points or different methods.
right. And this reevaluation definitely hits the VPN, doesn't it? The virtual private network used to be seen as a security tool itself.
It did, because it gave you that encrypted tunnel into the trusted corporate network.
Mhm.
But ZTA says that's not enough.
Why not?
Because just being inside the tunnel doesn't mean you should automatically be trusted to access everything. The VPN should just be seen as a remote access tool. It gets you connected. But once connected, ZTA principles must apply within that tunnel.
So access inside the VPN tunnel still needs to be dynamic per connection based on policy and context.
Exactly. The VPN provides transport. ZTA provides the actual access control decisions.
Okay, so to make all of this work, the dynamic checks, the different models, the integrations, the underlying network itself needs some serious capabilities.
It really does. The sources highlight 4 key attributes the network needs to support ZTA effectively.
What are they?
First, visibility. You absolutely need the ability to see what's happening, monitor users, devices, traffic flows in detail, collect logs and telemetry. So the policy engine has the data it needs to spot anomalies and make informed decisions.
Okay, visibility makes sense. Second,
Segmentation. The network needs to actually support breaking things down into smaller zones, whether that's macro zones, microsegments, or enclaves. You need the technical ability to enforce those boundaries.
right. And the last two sound like they relate to speed and responsiveness.
They do. Third is automation. You simply cannot do ZTA effectively at scale by manually configuring policies for every connection or responding to every alert. You need to automate policy enforcement, automate responses to detected threats. Human speed is too slow.
Got it. Automation is non-negotiable. And fourth,
Adaptability. The whole system, the network, the policies, the monitoring, needs to be able to adapt constantly. New users join, employees leave, new devices come online, new applications are deployed, new threats emerge daily. The ZTA framework has to maintain security posture through all that churn.
so wrapping this up, what does this all really mean? We've gone from a static castle wall.
To a dynamic, intelligent checkpoint at every single door, inside and outside the castle.
Yeah, security isn't a place anymore. It's a decision. Made constantly, based on context, enforced right at the resource itself.
Precisely. And it forces us to confront where the real risk has always been. Those old security domain models, LAN, WAN, apps, etc., they consistently show the user domain as the highest risk area.
People clicking links, using weak passwords, getting phished.
Exactly. Humans bypassing even the best technical defenses.
Which brings us to maybe a final provocative thought for you, the listener. ZTA moves policy enforcement closer to the data, sure, but it also ties access incredibly tightly to the observable state of the user's device and their immediate environment.
If your access can be cut off instantly because your antivirus is out of date or because the system detects unusual activity,
How does that fundamental shift, this constant granular per connection checking, change how organizations need to think about training, monitoring, and maybe even empowering their people at highest risk asset, the user?
because even with zero trust architecture, the human element is still there interacting with it all. How do we manage that interface effectively? Something to think about.